computer.
Okay. Hannah, can you see it?
No.
Well, what happened? Let me hit.
It was here too, and now it's not.
Yeah, we can't see it.
Oh, it turned off. I don't know why it turned off. I didn't turn it off, but who knows? Should come up now. Give it a second.
Okay.
Is that better?
You got it.
Yeah.
Make sure you maximize it so you can see it. It looks like on one of y'all's screens. Can you maximize it? Because it looks like you. It looks like at the Easley campus, yours is not maximized.
How do I do that?
Where's the mouse and just maximize it, just like a regular. Should maximize. Or maximize the.
Oh, yeah,
there you go.
Yeah, got it.
Well, there. Okay. All right. So we're going to go through chapter 1 and see if there's anything that's important in chapter 1. There's a few things that are. Remember, this section is pretty much definitions and reading. I don't know why. What section do we start with on the?
You said chapter 5.
Okay.
I thought 5.
Yeah, chapter 5. I'm thinking Math 120. I'm sorry. Let me get out of this. I'm thinking totally different. I suck. I know. Chapter 5. Thank you. 5A. Well, I saw that logic and I said, that's not right. So chapter 5, I think it's A, C, and E. You need to read. No sneezing in class. Not allowed to sneeze or cough. Fundamentals of statistics. That looks a whole lot better. All right, first definition that you need to highlight is that one right there. Statistics. There's two, well, I don't know what you call a word that has same word that has two different meanings, but that we have one here. I'm trying to get rid of this box. Okay, that was the wrong one. For some reason I can't.
Oh.
There. I'm having a little bit of issues with my mouse. It looks like it's hesitating, but they said that every campus was down this morning, so I guess something's going on. All right, statistics is the science of collecting, organizing, and interpreting data, and statistics are the data. Usually when you see the two words, statistics and statistics, used in different meanings, the statistics that talking about the data is usually lowercase. So you might want to make a note of that. Statistics with the uppercase, that's the whole field of collecting, organizing, and interpreting data. And lowercase statistics is the data that you're actually working with. And that's just...
So the first one is the lowercase?
The first one is the uppercase.
Uppercase.
The science.
Okay.
Science is uppercase, lowercase is the data. And the only reason you would need to know that is on any type of test or standardized test, especially if you're taking a placement test or a test to go into a program or whatever, you will see the uppercase and the lowercase. And that's the only thing you need to know there. Of course, y'all read all this stuff. Here's the second set of definitions that you're responsible for, and that's the population and the sample. And the best way to explain the population in the sample is Tri-County Tech as a whole would be the population. And if I wanted to sample, a sample would be the Anderson campus, or the Easley campus, or not the Pendleton campus, because the Pendleton campus makes up too big of a population. So if the sample is always your smaller version of the population, and if I wanted to do a survey on how many people were in the Marlboro Club, then I would take a sample of the Anderson campus and use that data to predict the whole campus in general. So the population would be the whole population of Tri-County Tech. That means the Easley campus, the Anderson campus, the Pendleton campus, and all the other little satellite campuses. I think we're going to have one in Oconee soon, or Pickens, one of the two. And the sample would be whichever smaller sample you're going to use. Now, why would we use a sample instead of surveying the whole population? Because of the two most important things in the real world. What are they?
Convenience.
Kind of time and
Money.
It's your parents' fault, don't worry. Time and what?
Money.
Money. You don't want to do and I'm using Tri-County Tech, but you could be a quality assurance director for all of the Michelin plants in the Southeast. And you could be bringing in 6 figures very easily, and your job is just to predict how many bad tires you're going to put out next year. And that's budgeted into the budget by what you say. And if you're going to use a population, that's talking about the Sandy Springs and the Star plant, which is not really in Stars in Anderson, but anyway, we're not going there. They put it in the Star district so the Star schools could get the tax money. But anyway.
So the plant right there.
Right over here. You're the wrong direction.
My bad. I don't know where I'm at.
It's over here.
Okay.
It's in Star, but it's really in Anderson, but they moved the lines so that Star schools needed the money. District 5 don't need any money. They got the Taj Mahal up here. They got plenty of money. All right, the population would be all the tire plants in the Southeast. Your sample would be the Sandy Springs plant. And you would go up there and you would pick out tires and you'd say, okay, I'm going to pick out 1,000 tires and there's 572 that are bad. So I'm going to use that 572 that are bad, and I'm going to make an analysis and a prediction that for the population of all Sandy Springs, and you would turn that into a prediction for the whole population. You would present that in the budget meeting, and then they would use that number of dollars based on your prediction to budget in for next year. Now, if you're way off, you get fired. That's all there is to it. And if you do good, then you get a bonus or you don't get fired. So that's why you have to make sure you know what you're doing if you're talking about a statistical analysis. But we're not going to have to get fired in this class. This is just an introduction, and it's just so you'll know what's going on when you're sitting in a meeting and somebody talks to you about a population and a sample. You know the sample is always the smallest and the one you're actually doing the survey for. Population parameters. All right, population parameters, that means that what are the variables you're going to use for the population? Put Greek letters. Just say Greek letters. What are the sample statistics? What variables are you going to use for the sample? And you're just going to use letters. Now, why do you need to know this? Is this important? Are the formulas different? No, the formulas are not different. But the only reason you need to know this is so you won't show your ignorance. Let's say that you're in a meeting in the future, and let's say that Zach works at Bosch, and he's an engineer at Bosch, or a line director at Bosch, or something at Bosch, and he attends these meetings with the executive officer that runs Bosch. And the executive officer has the assistant executive officer and all the department heads or all the engineers, and they're sitting around the table, and he's brand new, and they're given, the executive officer, the guy that runs the whole plant, is given a report on all the different lines and how they're doing as far as production. And he says, X bar for each plant, or X bar for this plant is so and so, blah blah blah, and the mu comes out to be blah blah blah. And what he's talking about, mu is a Greek letter. Mu is the mean for the population, which would be all the Bosch plants in the United States. And then X bar, since X is a letter, X bar means the sample mean for the Anderson plant. And Zach says, well, what's the difference between mu and X bar? And he probably get fired because the director probably says this guy don't know what he's doing. No, but that's why you wouldn't in a meeting say, well, what's X bar versus mu? They're the same thing, only one is with the sample, the X bar, because it's a letter, and the mu is a Greek letter, so in a meeting that is the population mean. And that's why you need to know what's the difference between a population parameter and a sample statistic. You could say population variable and sample variable. That's basically what it is. If you see a variable in statistics and it is a letter, it is dealing with the sample. If you see a variable and it is a Greek letter, then you are talking about the population. So it's just a little thing that will save you in a meeting from sounding like you don't know what you're talking about. Okay? And if you had a question, you would say, well, I see that your population mean is higher than your sample mean, and you know that because you know the difference between X bar and then you would say, why do you think that is? Is it because of the population difference, or is it because we are using this thing over here and they're not using it at the rest of the plants? Or you would ask a question, and then the person would know that you do know a little bit of statistics to know that those are the difference between the population and the sample. So it's a little thing about knowing what you're doing. And you'll see that later on when we're talking about population and sample. Next thing. And we're going to go down. I'm not going to go through that. Nah. We'll get to that later. Like I said, this section is very kind of boring because it's not any math involved. So you just have to wait until we get to chapter 6. Okay, random sample. Make sure you make a note of this box on page 289. Make sure you know what a random sample is, a systematic sampling, a convenience sample, and a stratified. A simple random sample is me putting every one of you, take a what do you call them things, a Post-it note, and they're all got to be the same size and the same color, and take 6 of those Post-it notes, and I put each one of your first and last name on those Post-it notes, and I fold them in half, and I put all of those 6 Post-it notes as folded in half that are the same color, the same size. I put them in a fish bowl, shake it up, and pick one Post-it note out of that fish bowl. That is a random sample. The key word with a random sample is that everybody has the same what? Equal chance of being picked. That's the secret to a random sample. If you're ever asked about a random sample on a test, always remember equal chance. Now, what if I fold one of those Post-it notes, instead of in half, I fold them in quarters? Is that a random sample? Not really, because the picker might be influenced into picking the quarter or not picking the quarter. So you've thrown the whole random sample off. What about a different color Post-it note? No, that's going to throw everything off. You've got to remember when you're dealing with statistics, Everything has to be neutral. Everything has to be on the same playing field. You can't ask 50 people this survey and change a couple of words and ask another 50 people and say that's the same survey. You can't do that. That's when you get into a little bit of bias and tendency. And remember, with a random sample and with most statistics, it has to be uniform. It has to be the same thing, whether you're dealing with a random sample or a systematic random sample. Now, a systematic random sample is a pattern. Everybody has, when you're using a symptom, I'll just make up one. Let's say I go through the phone book, and in Anderson County, the Anderson County pages, I pick every last name on every page. Then that would be a systematic random sample. Okay? If I picked every 100th name, that would be a systematic random sample. Something that has a pattern. If you write a program for a computer to pick every 5th phone number in the phone book, that would be a systematic random sample. A convenient sample. They put a star beside convenient sample because that's usually the least accurate. Why? Because it's the most what? Convenient. Let's say that Hannah works at a 80s hard rock radio station, and she wants to find out how many of her listeners listen to different music. So she says one day, I'm going to do a survey. How many of y'all like hard rock? Well, that's a convenient sample. Why is it going to be inaccurate? Because everybody's listening to her radio station, and what does she play? She plays hard rock. Duh. Okay? It would be like yelling out your, let's say you live in an apartment complex, and the apartment complex overlooks Main Street sidewalk, and Main Street sidewalk is where all the businesses are in your town. Okay? You yell out, how many of y'all walk to work out of your window? Okay? Well, why is that going to be a convenient sample? Why is it going to be inaccurate? Because everybody works on Main Street and everybody's walking to Main Street. That's a convenient sample. So you might want to put a star beside convenient sample and say convenient, but most inaccurate. Stratified. Stratified would be like voting precincts. Okay? Stratified would be like when you are breaking up into groups. So a state or a county can be broken up into voting precincts, and each county would be a stratified sampling of a state. So just think of grouping when you're talking about stratified. And I think they even give you examples. Yeah, there they are. And there's your examples. So make sure you know the definitions. And there's a caveman.
That's weird.
I watch a lot of. When I was at Clemson, I took a lot of the art and architecture because the teacher was pretty hot, and I took like 3 or 4 art major classes. Didn't even need the classes, okay? But she was pretty hot, and I loved Egyptian history, and I wouldn't have loved Egyptian history if I hadn't taken those classes. So I still, to this day, watch a lot of Egyptian documentaries on Discovery Channel, History Channel, things like that. And that caveman picture reminded me of this. You ever seen on TV how Egyptians are portrayed? Well, a lot of them are snaggletooths. A lot of them have overbites. A lot of them have a lot of underbites because there was a lot of incestual type things going on in the bloodlines. So they were all screwed up. So when you look at Cleopatra, and she was she was probably, because she was not fully Egyptian. But, some of those Egyptian queens that you see, and they're so beautiful, they really wasn't. They were pretty much, they were messed up. So anyway, when you watch TV and you see an Egyptian goddess and she's beautiful, she's got the makeup on and the straight teeth. No, not happening. They showed a couple of those queens and they were butt ugly, let me tell you. Woo!
Well, the only reason why they did that is because they wanted to make it seem like they
Pure.
were pure and more powerful than that.
And you could only do the pure bloodline at the beginning of time. You couldn't do the pure bloodline when you're talking about,
Incest.
Old Kingdom and New Kingdom, Egypt. That's way past the beginning. But anyway, they were all screwed up. Bias. That is a very important word to know. Now, if I asked you what bias meant, most of you would tell me it's leaning toward a certain view. And that's correct. You really see this today. Where do you see this today in the modern times? Anybody want to take a guess?
Politics.
Politics.
Media.
Go a little bit further. Where in politics? I mean, where do you see a leaning in politics today? See if y'all pay attention. Anybody want to take a guess? How about with the news?
Mm-hmm.
Yeah.
Do y'all see a leaning toward politics in the news?
Yeah.
Yeah. I mean, the president that we got now, he can't do anything right if you watch one side of the news. And then if you watch another side of the news, he's doing everything right. So that's bias. Bias is me saying, okay, let's say we got a presidential election coming up, and I do a survey. And I do a national survey across the United States, and I tell you that president or the nominee Smith is going to win because I went across the United States and I surveyed everybody across the United States, and they picked him or her, Smith. But what I neglected to tell you is that I surveyed South Carolina, Georgia, Mississippi, Alabama, Louisiana, Texas, and then I jumped over to Arizona, and then I jumped over to California, South California, down there near Tijuana. All right? Now, did I go across the United States? Yes, I did.
You picked primarily Republican states to sway
And I
them.
went across the United States, the southern United States. All right? Now, is that biased? Yes, that statistical survey is going to be biased. Or if I finagle the numbers and make the numbers come out to be biased. Now, a lot of people were saying in the last presidential election, what the hell happened? Hillary was supposed to win. And I don't know if you noticed or not, but in all the polls, and I predicted this. I predicted it because two of my students said that I was stupid last semester because I said that Trump was going to win. And they said, you're crazy. That's kind of, one of them said that's kind of ignorant to say that. And I said, well, you might think that, but watch the polls. And the polls, the only one that was changing was Trump. And if you watch the polls with Hillary, Hillary's numbers were not going up or down. And I noticed that, and a lot of other people noticed it. I wasn't the only one that noticed it. And those people were the ones that were saying that Trump was going to win because his numbers were going up and Hillary's was not doing anything. Because you can't win the Electoral College with New York and California. And that's why her numbers were not going up or down, because those two states were locked in for her and they were not going up. They weren't going down. And meanwhile, Trump was going up, and he'd go down a little bit when he screwed up and said something stupid. And then he'd go up, and hers was staying at 34, 54, 51, whatever it was in whatever poll, and they would not change. And any statistical person will tell you that a person that stays constant and doesn't change is not going to have that much power over somebody that is moving. And that's what happened. And she couldn't carry any other states except pretty much 2 states. But anyway, that's why we have the Electoral College, so 2 states don't dictate who we elect. And people cannot get that through their heads. And that was and that's not a bias. That's just people not reading the numbers. Okay. Types of statistical studies. All right, this is a standardized test question right here. All right. What is the difference between an observational study and an experiment? Well, I'll give you 2 good examples. Y'all ever seen these videos of people that are having sleep apnea, and they do a video of them sleeping in the green screen, in other words, at night vision, and they stand up and sleepwalk, and then they lay back down. They got all these wires attached to them. That's an observation. Just put sleep apnea person. Watching a video of sleep apnea. That is an observation. An experiment is when you interject something into the observation. Let's say that whenever a sleep apnea person wakes up, you shock them with electricity and wake them up. All right? That would be an experiment versus an observation. All right? Let's say that you are, let's say you're doing like horror movie I saw the other night. I'm a horror movie nut, and I watch horror movies all the time. And there's one called Exit 14 where Exit 14 doesn't exist. And these kids, of course, these are all stupid college kids that get drunk and get high, and they're going to get killed. And all of them got killed except for the one female survivor. She stayed alive. But they turned off Exit 14, and there is no Exit 14. It's just a ghost exit, and there's a guy there that kills everybody. All right, so the observational study would be watching people go down the interstate and getting off on certain exits. That would be the experiment. Would be putting a sign up on one of the roads saying, road construction ahead, exit 14 here. And watching people get off on exit 14 because they can't go down the interstate because you fixed it. That would be the difference between observation, watching people get off on different exits, and making people get off on exit 14. That's what they did in the movie. They put a sign up that said you can't go further, you got to get off here at exit 14. And then he killed everybody. All right? And an experiment, researchers apply and treatment to some or all of the sample members that observe affects the treatment. There is an interjection in there. Okay, let me give you a rat in a maze example. Let's say you put a rat, let's say a mouse, because a mouse is more cute than a rat, right? So you put a mouse in a maze, and you watch it, and you time it. Is that an observation or an experiment? Observation. It's an observation. You put cheese in 3 different places in the maze, that becomes not an observation, it becomes an experiment. When you interject something into an observation, it becomes an experiment. Okay? All righty. Probably going to ask for a placebo next. Treatment group, might want to write that down. A control group is members who do not receive the treatment. Let's say that you're doing an experiment and you're feeding people lettuce, carrots, and vegetables on both sides. Okay? So there's nothing different. But on the left side, you're giving them a red pill, and you're telling the people with the red pill that they're going to lose all kind of weight. And the ones on the right, you don't give them a red pill. That's a treatment group and a control group. Control is the treatment group is the one that you're giving something to. Control group is the one that you're measuring against. Okay? And this is where I think they bring in the placebo effect. Now, some of you may know what the term placebo means. Anybody think they know?
You don't have to raise your hand. We're laid back here.
Go ahead.
Meredith.
It's when you make someone, like, for example, you could give someone a pill and they could think that there was a purpose for it. However, it wouldn't have the same. It wouldn't
Doesn't
be the same
have any
pill
medicinal
give another
value.
group.
Yes.
Right. Yeah.
The placebo effect is, just think of the word
Placebo, sugar pill. Just say sugar pill.
Yeah.
There's an episode of Andy Griffith. It's one of the first episodes where, and I'd usually show it to the class, but with the internet the way it's acting today, I don't think I'm gonna try it. But Emma Watson, there's a new druggist in town, and her name is Ellie, and Ellie is by the book, and her uncle that ran the pharmacy wasn't by the book. He'd give everybody pills. He was a drug pusher, and he had this old lady that came in, and this old lady was dying of everything. And she came by, and she got a prescription, and there's a bottle of pills that cost a dime. And she came by, and the new Ellie Walker, the new pharmacist, was there, and she wouldn't give her the prescription because she didn't have a signed prescription from the doctor. And her uncle had been giving this woman the pills for a dime. Well, she didn't get her pills, and by the end of the week, she was dying. She was dying. She had everybody bring her food, and she was just sitting there laying on the couch eating all this food, but she was dying. And everybody was feeling sorry for her. And finally, the new pharmacist came to the house and gave her pills and said, "Hurry up! You need to get one of these pills in you, and take another one in another hour." And she said, "Oh, I feel better already." And then by the end of the show, she was up and walking around. And the whole point is, Sheriff Taylor went out to Ellie and said, "What made you change your mind?" "I didn't change my mind. I called my uncle. And my uncle said those were placebos. There's nothing wrong with her. It's all in her head." And and the pharmacist was giving her placebos so she wouldn't be dying. And I had a ex-mother-in-law like that. I mean, honestly, she thought everything was wrong with her. And that's just another story. We won't go there. But placebo effect, the sugar pill. I'm serious. There's certain people in the world that you just say hello to. You don't ask how they're doing. That was my ex mother-in-law. You just say, "Hey." That's it.
Keep walking.
Yeah, keep walking. So there's the placebo and the placebo effect. The placebo is the actual sugar pill, or the actual nothing that influences the person's thought or influences the survey. The placebo effect is the actual effect of the sugar pill, or whatever you're doing. So Meredith, you had it right. Good job. You're not going to fail now.
I said, hold on.
What?
I asked you to hold on.
Oh, I'm sorry. You got to speak up, girl.
I said, hold on.
Okay, you said, oh.
Because you were talking.
Oh, okay.
I was being polite.
Okay.
I don't have to be polite.
Okay, all right. Don't be polite. There you go. I'm trying to get it. This internet is not right. There. I hit the thing and it's going in like segments instead of flowing. Give y'all a few minutes to write that down. I figured you were just ad-libbing. I didn't know you were writing the whole word for word.
I'm not.
Okay.
I'm trying to be ad-libbed, but I have to.
Are you telling me that you're
it
slow?
says
Is that
first.
what you're saying? You're slow?
I'm slow.
Okay. You're challenged.
I'm challenged. Almost done.
That's why you need a book.
Sorry, I don't have one.
Oh, yeah, that's right. I told you not to buy one, didn't I?
Yeah, you
Yeah,
told
Hubert
me
said
not
not
to
to
buy
buy
one. So I didn't, and I'm just going to buy the activation.
It's all the Russians' fault. Blame the Russians. Or blame George W. Bush.
Okay.
Okay, you got it?
Yeah, I'm just.
You got the period? You sure you got the period? Okay. Next. We're not doing that one. I'm not going through that because that confuses people. Let's see what that is right there. Case control, I'm not going to worry about that. That means I'm not going to put it on the test. Margin of error. Nah, we'll get to that in a later section. Well, go ahead and write down margin of error. Margin of error is a gap. Think of it as a estimate. If you ask somebody for an estimate to paint your house, and they say, well, it's going to cost $500, give or take $100, then you know it's going to be between $400, $500, or $600 because it's $500 plus or minus $100. So the estimate is going to be $400 to $600. That's what a margin of error is. So if you did 76% with a margin of error of 3%, then that means it's going to be 73% to 79%. That's what a margin of error is. Where do you see margin of errors? Any of y'all watch the news? Where do you see margin of errors? Huh? No, that's where you see probability. Margin of error is usually in polls. Go back to your presidential polls. Margin of error, 2%. Margin of error, 3%. Down at the bottom of the poll, it'll say plus or minus 2% margin of error. That tells you if the statistics behind the poll is decent. What if you have a poll of 5%? Anything above 5% is not worth the paper it's written on. Okay? So that's why you have to look at the polls that you're being presented to on the news, because sometimes there ain't. I remember right before the first presidential debate, and I was all over Facebook with this. Let me tell you, I was all over it. The NBC poll come out the day before the debate, and it put so many people ahead of Donald Trump by 10 points. Cruz, it was Cruz. And I would not vote for Cruz no matter who was running. But anyway, they had Cruz ahead of by 5 points. And then down at the bottom, it had N is equal to 200 and margin of error is equal to 6%. So NBC basically just went out and they just measured 200 people and they did the margin of error to be 6% and they put it on there. Why? Why were they doing that? Because they wanted people to be influenced before the debate started. Okay? That and all the other polls were showing Donald Trump ahead. Now, I'm not making this up, okay? I'm telling you this because when you're dealing with statistics, no matter if it's at Michelin, at Bosch, or on NBC, or you're watching the news, you have to watch these things because bias is bad in statistics. Bad. And you have to watch it. Margin of error over 5% is not good because that usually tells you that you got a small group. The larger the group, the better the statistics. The smaller the group, the more biased it can be, or the bigger margin of error. Okay? So remember that. There's the margin of error. Sample statistic minus the margin of error, sample statistic plus the margin of error. You're always going to add it and subtract it. We're not going to have any questions on that on the test, but margin of error is something that you need to know just for your knowledge. You add it on the right, you subtract it on the left. So if somebody says, I got a 76% chance with a margin of error of 3%, then that's going to be 79% on the right. It's going to be 73% on the left, or 70%, whatever I said. You're going to subtract it, and you're going to add it. Huh?
So the lower on the...
Yes.
Okay.
Because you're subtracting it. That's not a test question. That's more of a, real world question. Here's an example right here. 52% with a margin of error of 3%. So the upper side would be 55%. The lower side would be 49%. So from 49% to 55% is where you're going to fall. And that's 5A. Now let's move on to 5C. What was that for? There we go. 5C.
Or not doing 5B.
No, I don't think you cover 5B. You'll have to look on the outline. That's what you're supposed to have in front of you.
Oh, sorry.
Yeah, you don't listen to me. That's fine.
Have it with me.
Statistical tables, frequency tables. Write that down. Frequency table is another word, is a 25-cent word for a chart.
Or a head count.
A lot of people, I don't know why they call it a frequency table, but
There's a lot of things in math that you hold your pinky up when you talk because, on Patrick.
Putting on airs.
That's what I thought about. That's what I thought about when you said that.
I am a SpongeBob fanatic. I love
Yes.
my two most favorite characters is Plankton and Squidward. That's my two favorite. I love when Squidward gets beat up.
But anyway, the one that I can't stand is Patrick. He's the one that I'd like to beat with a bat. He's so stupid. But anyway, this is a frequency table right here. It's made up of two things. It's made up of a class, and then it's made up of a frequency. A frequency table is nothing but a chart. Class is on the left, frequency on the right. And the frequency is a 25-cent word for head count.
So,
Blondes, brunettes, and redheads. In this class, we have blondes, we have 1. Brunettes, we have, I think,
5. And then redheads, none.
All right, that is a frequency table.
And Hannah, I'm assuming your hair is brunette.
I don't know.
Yes, it is.
And I'm assuming that
Meredith is a blonde.
unless she's changed her hair or something, I don't know. But that would be a frequency table. Now, let's say that I do a frequency table
How many people make A's and B's in the class? Then that would be looking like
like that, but I couldn't
do that until after the semester was over. But that's what a frequency table is. Do not let the word frequency table freak you out because it's such a long word. All it is a table or a chart.
And we're going to do some stuff with that. Relative frequency. Write that down. This is another question
That you might see on a standardized test. And they won't tell you what a relative frequency is. They'll just say, find the relative frequency of the following frequency table. And you'll
skip it because you have no idea what it means because you got all these big words, and all it is you put the
number, the head count over the total.
So let's go back up here. Just put head count over total. You got to find your total. Well, add up all the head counts. 4 and 7 is 11. 11 and 9 is 20. 20 plus 5 is 25.
So your relative frequency for your first one would be 4 over 25.
7 over 25. 9 over 25.
It'd be fractions.
Huh?
It'd be fractions.
Which turns into a decimal or a percent. Yes. So 4 over
25, which would turn into 4 over 25 fraction, which would turn into a decimal, which you could turn it into
to a percent.
7 over 25, 9 over 25, 3 over 25, and 2 over 25. And that's a relative frequency of your frequency table.
I like that.
And put your pinky up. Putting on airs. I'm still trying to figure out how they have
Fire underwater,
how they have Goo Lagoon underwater, and how they have boats.
underwater.
Do you want to try Camille?
Don't question it. Just accept it.
I know, just accept it. It's Bikini Bottom, so.
Want me to write Camille? Relative.
What?
Is it Yeah.
Relative frequency.
Do we need what she just said? I can't say it.
Cumulative?
Yeah, did we need
No,
that?
cumulative is right here. Cumulative frequency, I really have not understood what the real deal with cumulative frequency. You just put the first one down and then you add the second one and add the third one, and at the end you come up with the total.
I really don't know what the cumulative frequency is for.
That's stupid.
Yeah,
It's pretty stupid, but
it is a question that you might see on a standardized test.
What would we say? Add each one next.
yeah, you just start with the first one.
And then you add each one.
So if any of y'all can figure out what the cumulative frequency is used for, just make sure you tell me, because I have no idea.
I've actually tried to.
Googled it, and it really doesn't tell you anything except what the cumulative frequency is.
The only thing I can come up with is it shows you the distribution, and you can see that this is skewed right, which means that the
Most of
the
the
data is on the right-hand side, and the tail is on the
left-hand side.
side, so that means it's skewed right.
Huh?
Yeah.
Because the most. Huh?
See, on the cumulative frequency, it starts with 4,
And then 11, and then it's up on the 20, 23, and 25.
it's skewed right, which means tail is on the left. But that's not the way the frequency is. The frequency looks like a normal distribution, kind of. Well, the frequency is actually skewed left because of the 7 and the 9. So I really don't understand.
Understand what the cumulative frequency does.
I understand what the relative frequency does, but the cumulative frequency, I think they just do it just so they'll have something for you to be tested on.
I agree.
Find the cumulative frequency.
I don't really care about that. Data types, another question on standardized test.
Qualitative and quantitative. And all you got to remember there is quality, not what? Quantity. If you remember the old saying, quality, not quantity, then you'll remember what those two are. Quality has to do with the aspects of the production.
Quantity has to do with nothing but production.
Think of your mother. My mother makes chicken salad, and her chicken salad is out of the world because you can use it as a dip, and you can use it to make sandwiches out of. I mean, it's just the best chicken salad I've ever had. And she should put it in little containers and sell it, but all the regulations. She makes two good things. She makes chili for hot dogs and spaghetti out of this world, and she makes chicken salad. Those are two of the best things that she makes. And her chili for her hot dogs is heavier than the hot dog itself. I mean, it's made out of hamburger meat, and it don't look like that crap they give you at Skin Thrashers, that cardboard looking stuff. It's red, it's tomatoey, it's got paste, it's good. That stuff, I don't understand why people like Skin's hot dogs. Once you had one of my mama's hot dogs, Skin's is like crackers compared to. But anyway, she makes this chicken salad, and she makes it real good, and it's real good quality. And she put it in a bowl, put a top on it, and sell it, then that's great. But what happens when you start getting more and more demand for that good chicken salad? You got to make more what? More of it. When you make more of it, the quality goes what? Because the quantity goes up. And the whole purpose of manufacturing is to make the same quality but have the quantity. And the old saying is you can't have both. You can't have your cake and eat it too. It's real hard to have the quantity and the quality, and that is the problem with production. Think of McDonald's. McDonald's, when it made its first Big Mac, I remember when I was a kid, the Big Mac was huge. Huge. It's huge. It was huge. Now it looks like a biscuit. All right? Why? Because the price of beef goes up. Your hamburgers are going to get smaller. Just like, have you noticed that when you go to Zaxby's, you get this large T, and that sucker is large. But when you go to Subway or go to McDonald's, their large used to be like this, but what happens to it?
starts to get smaller. Have y'all noticed that when you get a large T at McDonald's now versus a large T at Zaxby's, the large T at Zaxby's is like this high, the large T at McDonald's is this high. And they because you're stupid people, you're not supposed to notice things like that. And you keep ordering it and you keep ordering it, but you don't make the difference because they make the cup smaller in little increments. And now basically what you're getting is a medium plus 1 ounce of tea. Because if you take the medium cup and you pour it into the large cup, their large cup now, you're only getting about that much more tea with a large.
Well, see, the thing is, that little bit of tea, I bet is filled with ice.
Oh, yeah. Oh, and that's another thing. When I order Cokes and Pepsis and stuff like that, I don't order with ice. Because what they do, Zaxby's is real bad about this. They fill up the cup with ice. So that way they only give you about half the ounce of the cup because of the ice.
I work at a restaurant. I work at Texas Roadhouse, and they train you to fill the whole entire cup with ice.
Yeah.
I was about to say the exact same thing. She did, because I actually used to work for Zaxby's a long time ago, and my boss at the time he's like, nah, you got to fill that sucker all the way up, just because they don't want to give you your money's worth. So.
Yeah. Well, think about it. They're paying for the Coca-Cola product, all right? The more they can stretch that Coca-Cola product out, the less they have to pay for it.
Exactly.
Okay? So if they can sell 2 large cups and only spend 1 large cup of Coca-Cola to fill both of those cups, they're making their money. That's why I order with no ice, because I figure it pisses them off. But anyway, but I don't do that with the tea because the tea is not cold, and you can't have tea without ice in it.
Oh Lord, no.
Because it's nasty. But anyway, that's quality versus quantity. Make sure you write that down, because that'll be on your test, and you'll also see it on any type of standardized test that you take in the future. And there it is right there on page 312. Blonde, brunettes, and redheads would be qualitative. Quantitative would be your weights or your heights or your ages. That would be quantitative. Make sure you understand bar graphs and pie graphs. I'm not going to spend too much time on that because most of y'all should have had Algebra 1 and Algebra 2. Y'all should know what a bar graph is versus a pie graph. So make sure you make a note of that. She says she's up again. I'm going to try it one more time.
While you're doing that, I'm going to go.
What's her name?
Christina Roberts.
Roberts.
While you're doing that, I'm going to go.
Christina Roberts. Oh, and those of you that need to take a break and go to the restroom or go get a drink of water or anything, or go get a Jack and Coke, anything like that, just, you don't have to ask, just do it.
A Jack and Coke?
Yeah, Jack and Coke. I'd like one, yeah. Huh? I'm kidding.
Have you ever tried Jack and Sprite?
Jack
Honey and Sprite.
Mm-mm. Oh, I haven't tried that Jack Honey. I've got all the different. I don't have the Jack Honey. I'm gonna have to try that.
Jack Tennessee Honey is my favorite. I will drink it straight.
Turn your video on, Christina, so I can see you. I don't know if she heard me, but hopefully she'll. Okay, everybody still see the. There she is. Everybody still see the board?
Yep.
Okay, good. Christina, do you still see it? Just shake your head if you see it. Okay. All right, so bar graph and pie graph, like I said, all of y'all have had pre-algebra, Algebra 1 and Algebra 2. That's something I shouldn't have to go through. Make a note on the bar graph versus histogram. The histogram is going to be, the boxes are going to be together. Okay? On the histogram, the black boxes are going to be side by side together, touching each other. That's the difference between a histogram and a bar chart. All right? Pie graph if I tell you that I make $100 and this is all how it's broken up, then you take 100, multiply it by 36%, you get $36 is spent here, $28 is spent here. So you take your total, which is $100, and you multiply it by the percent, which $100, it comes out to be just the dollar amount. But it could be $150, and you'd have to multiply $150 times each one of these, 0.28, 0.16, 0.08, 0.12, and 0.36. Now again, that's just a kind of a run over, but you should be able to read a chart and you should be able to work a chart. Make sure here that you know on a bar chart how to get the total. Let's see, there's 4, there's 7, 4 and 7 is 11, 9 is 20, 25. Okay? You add, you put a 4 here because that's 4, you put a 7 here, put a 9 here, and you add them all up. Okay? What should every bar chart equal? I mean, not bar chart, pie chart. 100%, exactly. That'll be some biased information or some false information. You see a bar chart and it equals 115%. You know you might as well not even read it because it's not any good. One of my questions on my test, one of my easy questions for bonus, says, what is Hubert's weights for his test and homework in the class? And one of the choices is 20, 60, 20 or 20, 20, 60, and the other one is 30, 30, 30. Now, which one's the right answer? 20, 20, 60, because that equals what? 30, 30, 30 doesn't equal 100, but people put it anyway. DA. You know, I put 10 questions on the test, so everybody should make a 40 or a 50. I still get people make 25s and 30s. It's sad. And these people procreate. They do. It's really sad. There's a sample pie chart right there. They'll either ask you the percentages or they'll give you a number like 1,000 votes and then 100 votes, and then you tell how many. That'd be 25 votes if it was 100 votes. 25 votes for Republican, 25 for Democrat, and 50 for Independent. And that's not true. Independents do not make up 50% unless you're at a, what do you call that place in Montana where they had that preacher, not the preacher, but no, not Montana, but Texas, Waco. We have one of them compounds. Yeah, you have some weird politics at these compounds, but they end up drinking Kool-Aid and stuff with cyanide in it. But they're pretty much weird. I'm more of an independent than I am a Republican. I think I'm a mix between an independent and a libertarian. Because I believe the Constitution should be read as is, and I think the left-wing liberals and the right-wing Republicans are nuts. So I'm pretty much in the middle.
Did I miss anything?
Hmm?
Did I miss anything?
Did you hear what she said?
Did I miss anything?
There, now, you enunciated. Thank you.
Did I?
All right. Like some of them people that call me and leave me a voicemail. How am I supposed to understand? Help me. And I'm supposed to call them back. I don't even know what they said. Okay. There's histogram. Here's a histogram. See the difference? A bar chart and a histogram is the same. One touches, one don't. Is it stupid? Yeah. That's about stupid. I don't understand. To me, that's not even worth going over.
So histogram bars touch.
Yeah. I'll show you how to do this in Excel when we get to the math section. I'll show you how to do the charts in Excel if you don't know how to do it. That's just for your knowledge. It's not that you have to use Excel. It's just something that I do to try to help students out. I'm just looking to see if there's anything else important for y'all for the test. Okay, that's 5C. Now let's go to 5E.
Are we just doing 5 today?
Yeah.
Yay.
Unless y'all want to go on and do more.
Hell no.
Oh, we can do more if y'all want to. I could put some extra sections in there if y'all want to.
Don't stress yourself.
Y'all suck. Y'all a bunch of lazy attitude disorders.
No, I'm hungry.
Correlation. Y'all ever watch The Matrix? The second Matrix? You drink too much wine, I have to pee.
What the heck?
Okay. Yeah, he's in a French restaurant and he goes, it's all correlation, cause and effect. I drink too much wine, I have to pee. It's correlation. In other words, cause and effect. Correlation. If I drive a BA Dodge four-wheel drive dually pickup truck versus a Prism, what do you call them, electric cars? Hybrids. Who's going to get better gas mileage? Hybrid. Cause and effect. But you're in a sardine can versus something that you can move around in, or SUV, whatever you want to call it.
I remember when we drove it last.
It took y'all like an hour to figure out how to drive my truck.
No, it was not me and Brianna.
Anyway.
It was the guys.
Yeah, then they couldn't open the dadgum hood.
No.
Yeah,
okay.
We had a guy out here.
Let me fill y'all in.
Okay, go ahead.
Okay, so we're sitting in class, and he looks out. We're upstairs in 202, and if y'all don't know, if y'all haven't ever been here, it looks over the parking lot. And so we're sitting there, and we see this guy struggling to start his car, and we can hear him. We can hear anybody outside in the parking lot. And so we hear him.
He had a dead
struggling.
battery.
Yeah.
Or a dead battery, depending on where you're from. Battery.
But while this is happening, he's making fun of his truck, and he's like, oh, he has a Ford or a Chevy.
It was a Chevy. You make fun of Chevys.
Yeah. He was making fun of his truck, and then he threw the keys to me, and he said, go get my truck and go help
Give
that
the boy
man.
a jump, because the security guard wouldn't give him a jump. So he just sat there.
He didn't say, go get your car. He said, go get my truck.
And half the class went to get my truck.
No.
Like 5 of them.
Okay, no. The girl that was with me, because she came to help me because he didn't know if he had his jumper cables, so she was going to go get hers from her car. Now, 2 of the guys got in there with us, but that wasn't my fault.
How many people does it take to drive a truck out of Hubert's math class? 4.
So we go to jump start this car while me and this girl go get her jumper cables. The guys are trying to open his
They couldn't open the hood of my truck.
Well, my boyfriend has a Dodge, so I come over there and open it right up, and they're like, how'd you do that? And, yeah, it was really funny.
It was funny. I wish I could have had a camera. I would have sent it videos. World's most famous videos. It was hilarious. Well, they finally got the Chevy. They finally got the bow tie started.
And then we're driving back to park his truck. And one of the guys...
They couldn't park it.
No, one of the guys found your knife. Good Lord. That dude had a freaking gun safe in his truck. Like, we're sitting there, and Brianna's stepping on a gun, and she's freaking out. And then these guys are like, pulls out a machete, and we're all like...
Well, if anybody tries to hijack my truck...
I don't think so.
Somebody's going to get hurt.
Yeah.
All right. So correlation, cause and effect. I don't know how we got on your truck, my truck with correlation, but anyway.
I don't have a truck.
Okay. Well, whatever. Correlation is when something is caused. Oh, we were talking about gas mileage.
Yep.
One of the best correlation examples for gas mileage is the weight of the vehicle versus gas mileage. And they did this all the time. You remember when gas was $5 a gallon? a while back?
Yep.
And everybody was heading to the gas stations because they thought it was the end of the world. Well, that was when all these news organizations were putting up these graphs saying if you drive an SUV that you hate nature and all this stuff, and you're killing the ozone layer and all this, and then that's when the Prius came out or the hybrid came out, and everybody was supposed to run out and get a hybrid because they were saving the environment and they could get 50 miles to the gallon and all this stuff.
Going off of that, did you know straws kill turtles?
Well, let's save the turtle. Good.
Guess who told me that?
Molly.
My hippie brother.
Well,
Yep.
does your hippie brother have a job?
He's actually in college to be a environmental.
How long has he
businessman.
been in college?
Oh, a year.
A year. He'll probably be in college for 6 or 7 years.
He's an ass.
Is he younger or older?
Oh, he's younger, but he's like 6'5".
Yeah, he'll be in
He's a
college
butt.
for about 6 years.
He's a butt.
Okay.
I don't like him.
Let's not talk about family now.
Love him. But
Okay,
I don't like
there
him.
you go. All right, scatter plots. Scatter plots is where you just plot the data as is. Okay? They're supposed to show you a scatter plot somewhere. I thought I went over correlation. Did I not go over correlation?
Oh, you did. You went back.
Oh, I went back. Hold on, let me show you a scatter plot.
The definition.
There's a scatter plot. Now, when you see a scatter plot, the first thing they're going to ask you about a scatter plot is the correlation. And all you're supposed to do is take a line. Let's use my handy dandy line maker. And put it in a direction that's somewhat in between all those points. Now, there's a formula called least regression that you can actually find the distance between each one and divide that distance. We're not going to go into that. You just need to eyeball it. Now, you got a bunch of them right here, and I don't even know what we're looking at. It looks like movies. But you got a bunch of them clumped right in here. And then you got a bunch that are up here, but so that's going to pull, these group down here are going to pull this line down toward them rather than these four right here because they're further apart.
So a correlation and a scatter plot is just that line?
Yes.
Okay.
Now, this scatter plot, and if you take your handy dandy, let me see if I can use this thing. You take and what I tell students to do with lines whenever you're dealing with math is which way do we read? Left to right. You always put a little car. Well, this is not going to work. There's your car. Okay? There. There's your car. And what is that car doing as you go from left to right?
Going up.
It's going up. So you've got a positive what? Correlation. That's a positive correlation. Now, what are they saying? What are these things? Production cost of movies versus gross receipts. There's a positive correlation with how much money is spent on a film for it. No yawning, Meredith. You're drinking coffee, all right? Boy, I like this. I can see students and I can see them when they yawn. Anyway, it's a positive correlation. So if the more money you put into a film being made, chances are the more money you're going to make on ticket costs, unless you pick a subject that really sucks. Think about it. What movie really sucked in your mind? John Carter was one of them. That was a stupid movie.
That was retarded.
Yeah. Think of a movie, since I love movies, think of a movie that you've watched in the last couple of years that really sucked, but had a lot of money put into it. Y'all have not seen any movies.
Fast and Furious 1.
Huh?
Anything after Fast and Furious 1.
Oh God, I never watch those. I think those are retarded. I'm not one of those guys that sit and look at the engine when somebody buys a new car. I don't sit there and look at the engine for 15 minutes. I'm not one of those people. Now, a truck is different. How much a truck can pull, that's me. But I don't care nothing about a Mustang or a Ferrari, or I don't care nothing about that. I'd rather have a good Dodge pickup truck. I will take a Ford because I got plenty of Fords on the farm, but they quit making the 7.3. And when they quit making the 7.3 is when I bought that Dodge. But anyway, nobody can think of a good movie. I mean, a bad movie.
That was worth a lot of money.
I can think of one. Expendables 3. That movie was not worth. I mean, the first one was okay, the second one was okay, but the third one, it was not worth the money. And they put a lot of movie in that. Look at these movies. John Carter, that one, yeah, it didn't bring in any money, but look how much it would cost to make.
Almost.
$300 million, and it only brought in $50 million. Somebody lost some money. But look at Avengers. Avengers only cost $225 million, but it brought in what? $625 million.
Yeah.
So there's a positive correlation. You know what I judge movies? I judge movies by who plays in them. Morgan Freeman. If Morgan Freeman's in a movie or Samuel Jackson's in a movie, I don't agree with their politics, but they're liberals, but I'd like to watch those two. I like to watch Denzel Washington. I like to watch Tommy Lee Jones. If Tommy Lee Jones is in a movie, it's going to be a good movie. Some of those actors, if they suck, and if they're going to be in it, the movie's going to suck. That's why all horror movies pretty much suck, because nobody's in them. All these actors that used to do porn or used to do this or used to do that, they're in the horror movies, and it's no good because nobody's ever heard of and they act terrible. Have you ever seen some of these horror movies? They are terrible actors. I watched one, and it was about this mummy that came back to life, and these people were trapped in the tomb, and the actors were, they were terrible. But anyway, positive correlation. What would be a negative correlation?
The opposite?
Well, opposite, left to right, what?
No.
Down. That would be a negative correlation. A constant correlation, what would a constant correlation be like? Think of a road. That's constant, meaning that you don't go up or down. So there's your three correlations. Positive, negative, and constant. Now those will be on the test because those are easy questions, and if you miss them, you don't tell anybody. You don't say, "God, I missed that one on correlation," because the person you're talking to is probably going to say you're an idiot because you're not supposed to miss that one. Okay? Y'all with me? All right, let's see what other examples they got. I have to change back to my mouse. They need, oh gosh, we need an Epson in here.
What's an Epson?
The Epson board.
Oh, the
I
one
need
upstairs.
an Epson. I can't do this. I'm gonna have to write on this thing, and that just ain't gonna cut it. That's a positive correlation. This is a negative correlation. Where you live decides how long you are gonna live. Look at there.
Oh,
Dang old Greece. You live to be what? Close to 80 years old. Where's the U.S.? We ain't even on there. We suck. We're not even on there. Bangladesh, they have 1,000 infant deaths for every higher life expectancy generally goes with lower infant. Well, yeah, that's so.
In Greece, they do not have a high infant mortality, and they have a high, so that's a negative correlation. Bangladesh, you don't have a chance. First, if you don't die when you're born, you don't live till you're, what, 58? Pakistan's not much better. But dang old Greece, Canada, and Australia, I'd like to live in Australia. Yeah, down there, they got a prime minister that if you break the law or whatever, they just kick you out of the country. So I like that place. I don't know about Canada. I don't think I could handle Canada. Greece, I could probably handle Greece.
Greece would be cool.
Yep. I think I could pass as Greek. Who knows?
Just put a thing on your head.
Or Mexican, huh?
Just put a thing on your head.
Yeah, put one of those things on my head. All right. That's pretty much correlation. That's the only thing I'm going to ask you on that. I don't know if they're going to ask you to figure the correlation. Let's see if they give you a formula. That would be a constant correlation right here. That's a positive. This is more of a constant. I'm looking to see if they want you to calculate the... I don't think they are. I think that's... Yep, they do want you to. Well, the correlation is the y. I meant the m, your slope. So they're going to, I don't think they're going to, yeah, here's the correlation coefficient. 0.77 right there.
But it doesn't
But they don't
give
give you a formula. I'm looking for the formula. They might give it on the next page or something. Let's see if they put it on the next page. I don't see it. I don't think they do. Causality. I drink too much wine. I have to pee. And he talks about that in Matrix 2 for some of y'all that hadn't seen it. He actually talks about it. What happens if you drink too much water? Same thing. You have to go to the restroom. Causality, correlation, they're both the same. Okay, that's it. Cell phones and driving. What would that be? Probably be a positive correlation. The more you talk on your cell phone, the more wrecks you're going to have. Pretty much. Texting is even worse. You ever see my truck go off the road, that means I'm texting.
You need an Apple Watch.
Huh?
Yeah, Apple Watch.
What's an Apple Watch?
What? You just talk.
What good would that do?
So you don't text and drive. It takes out the middleman.
Oh, okay.
You just talk to it.
That's
Whenever-
5E, yeah.
No,
I go
just
down the
when-
road in my truck talking to my... No, I ain't gonna do that.
No, it's like whenever somebody sends you a text, you press the speak button and you say what you want to text, and it sends it for you.
Well, I can do that
And
on my
you can
phone. I
answer-
hit the microphone.
And you can answer calls on your.
Oh, okay.
It just takes out the Bluetooth of a car.
Oh, okay.
If that,
5E, that's 5E. So make sure you know what correlation and causality is.
we didn't go over causality,
You drink too much wine, you have to pee.
so it's the same.
The
thing as
causality is
correlation.
what's caused by the correlation. The correlation, the more wine you drink, the more you have to go to the restroom. That's the causality. Is that a positive correlation or a negative correlation?
So it's the
It's
effect.
positive, yes. What's the effect of the correlation of the weight of the car versus the gas mileage?
It goes down.
When you go to the, what's the effect on you when you go to pick out a car? Are you going to pick a big car or are you going to pick a little car? You're going to pick a little car. That's the effect.
I want to pick a big car.
Well, then you're going to pay the gas mileage. All right, now that's chapter 5. Now, chapter 6, I'm going to just go into chapter 6. I'm just going to show you what we're going to be doing because that is the actual math. Somebody look on your outline. What sections do we cover in 6? A, B, and C? Okay. And then A is characterizing data. giving data names, like the mean, median, and the mode, and all that good stuff. Now, like I said before, most of y'all know how to do this section, but where I run into problems is when people don't know how to find the standard deviation and the variance. And then they don't know how to find the z-score and stuff like that. So you are welcome to try problems in this section up to a certain point. I think you'll be able to do 6A okay. But 6B is when you start getting into the normal distribution and the, measures of variation, which means you get into the variation and the standard deviation. So what I suggest y'all do is do all of Chapter 5 homework, not all, 5A, 5C, and 5E, and read Chapter 5. And you can go ahead and start on 6A, either reading or doing the homework or both. But I don't want you to go to 6B yet, okay? So I meant 6C. Is it A, C, and E?
A, B, C.
Okay. Don't go to B yet. Just do A if you want to go to Chapter 6. And what time's class over? Like 10?
Yep.
Okay. We'll call it today. Let me go ahead and get the roll. I'm not gonna let y'all out early every day, okay? So y'all just don't expect that too much.
I'm getting my access code today.
Okay. Does anybody have any questions on the access code or anything like that? Anybody have any questions at all? Today's the last day to add or drop, isn't it? I wish we could get a few more people in here, make it more fun with more people. But I think some people are kind of iffy about taking this class because they don't know about it. Zach, are you going to take Calc 1 again?
I'm not sure.
Well, I'm teaching it in the fall. If you want to take it, you can sign up for the Anderson campus. Where do you live? Easley?
Well, I live in Greenville, but
Okay.
I was in Bridge.
I'm sorry,
last
what did you say?
I was in Bridge.
Okay. Well, if you want to take it again, you can Skype in pretty much if you want to. And I have a good success rate in calculus. So I have a lot of people, very few people fail my calculus class.
Do I have to sign up now?
Yeah, you need to sign up too.
Okay. Well, can you make it okay for me to sign up?
I think I've already done that.
Wonderful.
All right. Attendance. And set attendance. Oh, this is one I have to do separately. This sucks. All right. Select Wednesday, and this is Hannah is here, so I just hit yes. They have it separated into 3 classes, so I have to do the. Okay, go back. And then the second one. And that's all of y'all. Y'all are here. And back. And then section 5 is our friends at the Easley campus. The reason I call you Meredith is because I want to say Villa instead of Villa. That's why I want to say.
That's what it is. Yeah.
It is Villa?
Yeah. Mm-hmm.
Okay. Well, I didn't want to. And Zach, for some reason, Zach sticks out better than your last name, so that's why I call you Zach. Usually I go by last names, but anyway, I'll shut up. All right, who's got questions? Does anybody have any questions?
I'm keeping out about this.
Okay. Yeah, y'all got questions. Hannah, you good? Have you got your access code and everything?
Yep. Good.
Okay, Zach, y'all got y'all's access code?
Yeah.
Yes.
Okay, Christina, you got yours? All right. Well, I will shut off the do jigger right now. Hold on. I'll cut off the